Okay, ready to dive in. Today we're cracking open The Telomerase Revolution by Dr. Michael Fossel.
He's got this really interesting theory about why we age.
And it all comes down to these things called telomeres.
Have you ever heard of those?
Oh, yeah. They're actually pretty fascinating.
Dr. Fossil, he starts off by comparing aging research.
To that classic story, the blind men and the elephant.
Oh, right.
Where they're all feeling different parts.
And they think they've got it all figured out.
Exact.
Each one feels a different part and comes up with a totally different description.
And he says that's kind of been the problem with aging research for a long time.
Scientists kind of get hyper-focused on, one specific aspect.
Like aging genes or free radicals.
But they miss the bigger picture, you know what I mean?
Okay, so are you saying these aging genes aren't the be-all and end-all?
Well, it's not quite that simple.
Dr. Fossil, he points out that it's not so much about,
How long we're programmed to live.
but more about how these genes actually change their behavior as we get older.
He uses this really, really interesting analogy with cell phone contracts.
Okay, cell phone contracts. Aging.
I'm listening.
All right, so imagine this.
What if your cell phone contract was only 2 months long?
You'd always have, the newest, coolest phone.
But it would cost you a fortune.
Right?
You'd be paying through the nose for that.
Exactly.
But then on the other hand, imagine if you had a 20-year contract.
Super cheap, right?
But you'd be stuck with that same phone?
Yeah, eventually it would be, totally obsolete.
Like a dinosaur.
Exactly. And Dr. Fossil says our cells, they face this kind of similar dilemma.
So our bodies are trying to balance.
Staying brand new and not becoming totally obsolete.
And telomeres play into this somehow.
They're a big part of it. So there's this scientist.
Leonard Hayflick.
And he made this groundbreaking discovery that our cells can't just divide forever.
Okay.
Makes sense.
There's a limit.
And it's called the Hayflick limit.
And it's basically like a countdown clock for our cells.
And guess what controls it?
Our telomeres.
You got it.
So instead of looking for a fountain of youth gene,
We need to understand this cellular countdown clock.
this is where it gets really interesting.
What exactly are telomeres?
Okay, so picture your DNA like a shoelace, right?
Okay.
I'm picturing it.
And those little plastic tips at the end?
The ones that stop them from fraying.
Right.
Those are kind of like your telomeres.
So they're like these protective caps on our DNA.
Exactly. They protect the ends of your DNA strands.
And every time a cell divides, those telomeres, they get a little bit shorter.
Wait, hold on.
You're telling me my DNA is literally fraying as we speak.
You could say that every time your cells divide.
To repair damage or just to keep things running smoothly.
Those telomeres, they take a little bit of a hit.
And the really fascinating thing is,
It's not just about things wearing out, right?
it's how our cells actually react to those shortened telomeres.
And that reaction, that's what really drives the aging process.
It's like this whole chain reaction gets set off.
Wow, okay, so it's not just wear and tear.
It's our own bodies responding to that wear and tear. That's pretty amazing.
It is pretty wild, isn't it?
And it's all thanks to these little telomeres.
Telomeres, who knew?
They're the unsung heroes of our cells.
This is really making me think differently about aging.
That's what we're here for. Shake things up a bit.
Yeah, mission accomplished. But I have to ask,
Yeah.
if these telomeres are so important, is there any way to, keep them from shortening or even lengthen them again?
Now that is the million-dollar question, and it leads us to one of the most exciting frontiers in aging research, telomerase. But we'll save that for next time.
Okay, so my cells are dividing, my telomeres are shortening. It sounds kind of scary, to be honest. What happens when they get too short? Do they just, stop working?
It's not so much that they stop working, it's more like they hit the pause button. It's like a built-in safety mechanism.
Think of it like this. Your cells, they've got this incredible alarm system, right?
Right.
And when those telomeres get down to a certain length,
It's like the alarm bells start ringing.
and the cell goes, whoa, hold up, something's not right here.
So it's less about things wearing down.
And more about our cells, hitting the brakes themselves.
You got it. The cell goes into this state called senescence.
Senescence.
Yeah, it's basically like cellular retirement.
Cellular retirement.
It stops dividing,
Okay.
which, it seems like a bad thing, but it's actually really important.
Why is that?
Well, because if a cell with damaged DNA keeps dividing,
That's how you get problems like cancer.
so it's like a preventative measure.
Exactly. It's pretty ingenious when you think about it.
It is pretty amazing. Our bodies just kind of doing their thing.
Right. Like this perfectly orchestrated system.
But it still makes me wonder, why do we age at all then?
That is the million-dollar question.
And Dr. Fossil, he brings up this whole evolutionary perspective.
Okay, I'm intrigued.
So, we always think about living longer, right?
Yeah, who wouldn't want to live longer?
Right, but what if we never aged at all?
Immortality.
Exactly. Sounds pretty great on the surface, right?
Yeah.
But Dr. Fossil argues that it might not be as ideal as we think.
Wait, really? Why not?
Well, think about it. If no one ever aged,
We'd be stuck with the same genes,
same adaptations.
even as the world around us is changing.
Exactly. We'd lose that ability to adapt and evolve.
Huh. That's a good point. I hadn't thought about it that way.
It's kind of a trade-off, right?
So, individual aging, it's like the price we pay for the species as a whole to survive.
In a way, yeah. It's all about that long-term survival of the fittest.
Fascinating. But let's be real. I think most of us would still be okay with putting off those trade-offs for a little while, right?
Of course.
So is there anything we can do to slow down this whole telomere shortening thing?
Well, that leads us to one of the most exciting areas of aging research, telomerase.
Telomerase. Okay, I've heard that word thrown around.
It's kind of a big deal.
What is it exactly?
It's an enzyme that can actually lengthen telomeres.
Wait, seriously. So we can actually make those protective caps on our DNA longer again.
That's the idea. And you know what's really interesting?
What's that?
Dr. Fossil, he tells the story about having dinner with this Russian scientist, Alexei Olovnikov. And guess what? Olovnikov, he's actually the one who first proposed this whole telomere theory of aging way back when.
Get out of here. So this whole time we've been talking about telomeres,
Yeah.
and it all goes back to, like, a dinner conversation.
Well, not exactly a dinner conversation.
Oh, Olovnikov, he was pretty much ignored for his work back then.
Oh, no, really.
Yeah, which is a shame because his insights were crucial.
So telomerase, this enzyme that can lengthen telomeres, that's all thanks to Olovnikov.
In a way, yeah.
Wow, talk about a legacy. But, okay, back to telomerase. If we can, harness its power, are we talking about, immortality here?
Well, immortality might be a bit of a stretch, at least for now.
Okay.
But there are definitely some exciting possibilities.
Like what?
Well, there are these companies like Geron and Sierra Sciences.
I've heard of those names.
They're kind of leading the charge in developing therapies that can activate telomerase.
So they're trying to find ways to, flip the switch on telomerase in our bodies.
Exactly. And they're making some really promising progress.
That's amazing. So is this telomerase therapy something I can just, pick up at the pharmacy?
Not quite yet. It's still early days.
But Dr. Fossil, he does mention some natural substances that might have telomerase boosting potential.
Really? Like what?
Well, there's astragalus root, for example.
Astragalus. Okay, yeah, I've heard of that one. Isn't that like a Chinese herb or something?
Yeah, it's been used in traditional Chinese medicine for centuries.
And now it might hold the key to longer life. That's wild.
Well, it's not quite that simple. More research is needed to know for sure.
Of course, of course. But it's still pretty exciting, right?
It definitely is. It just goes to show that the search for ways to activate telomerase is on, and there's a lot of potential there.
That's really promising. But let's say, just hypothetically, we could flip that telomerase switch tomorrow.
Okay, let's say we could.
What would that even look like? Would we all just, stop aging in our tracks?
Well, it's probably not going to be suddenly hitting a pause button on aging,
Yeah.
but it's more about extending our health span.
Health span. What that?
It's basically the portion of our lives where we're feeling our best physically and mentally.
So instead of just living longer, it's about living healthier for longer.
Exactly.
So it's not about, becoming immortal.
It's about, stretching out those golden years.
When we're feeling our best.
Exactly.
A world where,
Heart disease, Alzheimer's,
human arthritis.
those are no longer just inevitable parts of getting older.
Wow.
That would be incredible.
What if we could,
Stay healthy and active.
well into our, what we now think of as, old age?
Exactly. It could be a game changer.
It's mind-blowing.
But, okay, let's be real.
There got to be some downsides.
Side effects. We're talking about messing with our biology here.
Right, right.
Well, Dr. Fossil, he does address that.
And he's pretty upfront about it,
He says there might be some side effects.
Okay, like what?
He mentions things like,
Maybe an increased appetite?
or feeling a little tired at first,
Okay.
while your body kind of kicks into repair mode.
So, giving your body a major software update.
Exactly.
There might be a few glitches at first.
But ultimately, it's a good thing.
Okay. That makes sense, I guess.
It's like giving your body the tools.
To repair and rejuvenate itself.
On a cellular level. Pretty amazing, right?
It is pretty wild when you really think about it.
But that brings up a whole other question.
We're talking about, potentially adding decades to our lifespans.
What would that even mean for society?
Right, right. That's where it gets really interesting.
Dr. Fossil, he dives into some of those big picture questions.
And it's kind of mind-boggling, to be honest.
Like what? Give me an example.
Well, imagine, like, families with 4 or 5 generations.
All living and interacting together.
Wow, that would be something else.
And work, retirement, those
Yeah.
would have to be completely rethought.
Exactly.
It's almost impossible to imagine all the ways our world would change.
A whole new ballgame.
It really makes you wonder,
If we had all this extra time,
what would we do with it?
right, what would we do with all that time? Dr. Fossil talks about
People pursuing multiple careers.
or finally having the time to travel the world.
Or just, really diving deep into their passions.
It's kind of an inspiring thought,
like this huge opportunity.
but it's also kind of daunting, you know?
It's a lot to wrap your head around.
It really is.
It makes you think about aging in a whole new light, doesn't it?
It does. If it became more of a choice, would we appreciate our time even more?
That's a really profound question.
And it gets to the heart of what Dr. Fossil is arguing.
He says, instead of just trying to find a cure for every single age-related disease,
What if we tackled the root cause?
cellular aging itself.
Exactly. What if aging itself wasn't inevitable?
Wow, that is a lot to process.
It is, isn't it?
Well, I think it's safe to say that this deep dive has definitely given us a lot to think about.
I'll say.
The telomerase revolution might still be a ways off.
But just understanding the science behind it, the potential, even the ethical questions.
It's absolutely fascinating.
It really is.
Well, thanks for joining us on this journey into the future of aging.
Thanks for having me. It's been fun.
Until next time.